All right, for number 8, it says the following data set gives the average home value in dollars for a city at 5-year intervals. Our input values, which are our x values, are our years, and they go by fives: 70, 75, 80, 85, 90, 95. And then our y values, or our f values, our function values, are our output. And you're just, by process of elimination, going to see what happens to your output values. F, which is the value, is constant for the given x values. So that means that it's unchanging depending on your x coordinates. And then B, it says the function is increasing for the x values. Well, as the x increases, our function values also increase. So I think B is a possibility. C says that f increases just until the 1980, and then it starts to decrease. That's not true. And F is decreasing for the given x values. So our answer is B, increasing. Right, number 9. The tire of a moving bicycle has a radius of 16 inches. If the tire is making 3 rotations per second, find the bicycle's speed in miles per hour. When we do rotation, we're thinking about going around. We have our tire. So here's our tire. We're going around. We're making 3 rounds. That's 1 rotation. And that is the same as the circumference of a circle, or the circumference of a tire. So circumference is pi times diameter. We know that the radius of our bicycle tire is 16. If the radius is 16, then that means our diameter is going to be 32 inches. When I find the circumference, that's going to be 1 rotation around my tire. The circumference then is pi times 32, and we'll work that one out. Pi times 32 is approximately 100.5 inches. So that's 1 revolution around, or excuse me, 1 rotation around. It says that it goes 3 in 1 second. So if I take the circumference times 3, that'll be the distance that the tire rotates in 1 second. 100.5 times 3 would be 301.5 inches. And then that's inches in 1 second, so inches per second. I'm just going to do a conversion because I want to change inches per second into miles per hour. I start out with 301.5 inches in 1 second. Ultimately, I want to get to miles per hour. So the first thing I'm going to do is change inches to miles by multiplying by 1 foot over 12 inches. I'm going to go from inches to feet and then to miles. Because inches is in the numerator to begin with, I want to put inches in the denominator so that they'll cancel out. There are 5,280 feet in 1 mile. And so that'll get rid of my inches and my feet and give me miles. And then I want to take and get rid of my seconds, and I want to change my seconds to hours. I know that there are 60 seconds in 1 minute and 60 minutes in 1 hour. And so I can reduce the inches and the feet. And I'm left with miles, which I wanted in miles. And then I can reduce the seconds and the minutes and be left with hours. I'm going to multiply everything in the numerator, everything in the denominator, and then simply divide those. My numerator, I'm going to take 301.5 times 60 times 60 My numerator is 1,085,400. The denominator, I'm going to take basically 1 times 12 times 5,280 times 1. So 12 times 5,280. And that's 63,360. And then divide. And you should get approximately 17.1 miles per hour, which is C. Number 10 is not really a very difficult one. It says solve the equation graphically. All I'm going to do is I'm going to take the left side of the equation, which is the absolute value of 5x minus 3. I'm going to write it as its own equation, as y equals absolute value of 5x minus 3. And then I'm going to take the right side, make it its equation of its own, y equals 2 times the square root of x plus 1. Going to graph them both, left and right side, on the same graph, and just look to see where they're equal, which is where they intersect each other. So let's do that real quick. So all I've done here is made an equation for the left side of the original equation, an equation for the right side of the original equation, and then I'm going to graph them both on the same coordinate plane and look where they intersect each other. So that's all I'm doing, is where they have points in common or where they are equal. And when you're solving an equation, you're solving for x. So we're only concerned about the x coordinate here. We have one that's approximately 0.2 as a solution, and the other one which is approximately 1.2 as a solution. So you should have 0.2 and 1.2. Alright, for question 11 it says find two functions defined implicitly by the given relation. Obviously, if you look at your multiple choice answers, all you're doing is solving for y here. So my original function is x plus y squared equals 49. I'm going to get y by itself. Subtract x from both sides. Y squared equals 49 minus x. And then take the square root of both sides to get y by itself. When you take the square root of a number, you have it plus or minus that value. So ultimately we have plus or minus the square root of 49 minus x, which is C. Number 12, write the specified quantity as a function of the specified variable. 12, a square is inscribed in a circle. Write the area of the square as a function of the radius. It's just a matter of how you draw your picture. So I have a circle. I'm going to draw a square inside my circle. Keep in mind that a square, that's going to be x and x. The center of my circle will be right here. And we want to write the area of the square as a function of the radius. The radius would be that diagonal as well, which is r. I'm going to move my x's here just a minute. That's the sides of the square. There's our radius, r. And I want to show the area of that square in relationship to the radius. So instead of writing an x for the sides, I want it in terms of r. So I'm going to treat this as a triangle. This, when I have the diagonals of a square, that's a right angle, which makes us have 45 degrees and another 45 degrees down here. So we have a 45, 45 90, right triangle. I'm going to draw just that right triangle, another version of it right here. So again, we have R and an R, and for 45, 45, 90, it would be the side, the two legs are congruent, and the hypotenuse would be whatever the length of the leg is times the square root of 2. So that would be R square root of 2 times the square root of 2 would be the hypotenuse, which in this case would be the same as our x. So if I were to take the area of my square and say x times x, which is x squared, and I replaced that x with r square root of 2, I would now have r square root of 2 squared. If I square r, that's going to be r squared. If I square the square root of 2, that's going to be 2. So I get 2r squared would represent the area, which is D. Okay, for number 13, I'm going to find the domain of the function. I can just graph that. I have some options for what I can have. I can also just do that without graphing it. I'm looking at the domain. I want only the x values. I start out and say, okay, x is all real numbers. It can be anything. Now I want to go back and I want to say, well, is there anything that would cause me to have a value that wouldn't work for x here? And that's when we have a value for x that allows the denominator to be 0. So I'm going to take the denominator, x minus 5. I'm going to say, well, x minus 5 cannot equal 0, and solve it so I know that x cannot equal 5. Anything else is going to work. So as I go along my x values, I can use anything from negative infinity up to 5, and then after 5 to positive infinity, which would be A. Number 14, it says give the equation of the function whose graph is described. The graph of y equals the absolute value of x. So we're going to take, that's our original function, and it says we're going to reflect it across the y-axis, which means when we reflect something across the y-axis, the x-coordinate is going to change. So the first thing that happens is this, where we reflect it across the x-axis. So we go from y equals the absolute value of x to our first step would be y equals negative, absolute value of negative x, where we reflect it across the y-axis. This graph is then vertically stretched by a factor of 8.8. When we do a vertical stretch, the whole function is multiplied by the factor. So that would be the second thing, is to take our whole function and multiply it by 8.8. And so now that's our function. And then the third thing it says is the graph is shifted 3 units down. When it goes up or down, anything happens to the y coordinate, it's added or subtracted to the whole function. So we have y equals 8.8 times the absolute value of negative x minus 3, which would be C. Number 15 just asks if we have a one-to-one function. One-to-one functions will pass the vertical line test and the horizontal line test. This one passes the vertical line test. It just doesn't pass the horizontal line test. So it's not a one-to-one.